Good day, class. It's good to have you here again. Let's settle in and see what today's lesson is all about. In our last lesson, we learned about sequences and how they follow specific patterns. Today, we'll take this further by exploring how to derive a general term for a sequence. We will also introduce a new concept, series. Grab your notebook and let's get started. Note down the following. In many cases, it simplifies calculations if we can derive a general term for a sequence. For example, the sequence below can be expressed as this, where 4n-3 is the value of the nth term. Note that the nth term represents the position of a number in a sequence. For instance, if n equals 1, it refers to the first number in the sequence. If n equals 2, it refers to the second number. And so on. Now let's verify this general term. When n equals 1, we substitute 1 for n into the general term. This gives us 4 multiplied by 1 minus 3. According to the Bodmer's rule, we will calculate the multiplication first. 4 multiplied by 1 is 4. 4 minus 3 equals 1. When n equals 2, we substitute 2 for n into the general term. This gives us 4 multiplied by 2 minus 3. 4 multiplied by 2 is 8. 8 minus 3 equals 5. Other terms in the sequence are also derived by following this same pattern. Suppose we want to find the 100th term in the sequence. We substitute 100 for n into the general term. This gives us 4 multiplied by 100 minus 3. 4 multiplied by 100 is 400. 400 minus 3 equals 397. By deriving the general term for a sequence, we simplify our work significantly. This way, we don't need to calculate each term individually to find a specific term in the sequence. Now, let's dive into another related concept. Series. A series is the sum of the terms in a sequence. For example, if we add the numbers in the sequence below, the series becomes this. When a series ends after a finite number of terms, it is called a finite series. Here is an example. However, when a series does not end and continues indefinitely, it is called an infinite series. Here is an example. Follow me, let's explore some notations commonly used to represent series. To represent a series more compactly, we use the summation notation, also known as sigma notation. The Greek letter sigma indicates summation. Note: the sigma symbol looks somewhat like a stretched letter, E, but it is different from the English letter, E. Here is the general formula for summation notation, where I is the index of summation, indicating the starting value. M is the lower limit, showing where summation starts. N is the upper limit, showing where summation stops. A sub I is the general term of the sequence being summed. Let's see an example to understand how summation notation works. Example 1. Calculate the sum of the first 5 positive integers using summation notation. Solution. The summation notation can be represented as this. This means we are summing all numbers starting from 1 and ending at 5. Expanding the summation, we have S equal to 1 plus 2 plus 3 plus 4 plus 5. Add these terms together with your calculator. The result is 15. Therefore, the sum of the first 5 positive integers is 15. Now that we've explored summation notation with a simple series, let's take it a step further by working with a sequence defined by a general term. Example 2. Find the sum of the first 4 terms of the sequence, defined by the general term below. Solution. The summation notation can be represented as stated below. This means that we are adding the terms starting from 1 to 4 using the formula 2i plus 1 for each term. Now, let's substitute the values of I into the general term. When I equals 1, we substitute 1 for I into the general term. This gives us 2 multiplied by 1 plus 1. We will calculate the multiplication first. 2 multiplied by 1 is 2. 2 plus 1 equals 3. When I equals 2, we substitute 2 for I into the general term. This gives us 2 multiplied by 2 plus 1. 2 multiplied by 2 is 4. 4 plus 1 equals 5. When I equals 3, we substitute 3 for I into the general term. This gives us 2 multiplied by 3 plus 1. 2 multiplied by 3 is 6. 6 plus 1 equals 7. When I equals 4, we substitute 4 for I into the general term. This gives us 2 multiplied by 4 plus 1. 2 multiplied by 4 is 8. 8 plus 1 equals 9. Now that we have calculated the first terms of the sequence, we'll add them up to find the sum. Add these terms together with your calculator. The result is 24. Therefore, the sum of the series is 24. Assignment. Write down the following assignment and attempt it yourself. Solve the following. Take your time to walk through these questions carefully. In conclusion, we have learned how to find the nth term of a sequence. We also learned how to find the sum of a series. Watch out for our next lesson, where we will explore arithmetic progressions. You are doing great. Keep pushing forward. The more you practice, the clearer it becomes. Thanks for joining me today. Goodbye for now.